which are quite popular. One is called classification, one is called clustering. And it is important to understand the difference between classification and clustering. In a classification, which is considered to be an easier task as compared to clustering, you are given the class, you are given the groups. For example, there are some students who are in mechanical engineering, and there are some students who are in the electrical engineering. And now these two classes are given to you, electrical engineering and mechanical engineering. So a data for a new student comes and you have to tell whether that student belongs to mechanical engineering or electrical engineering. So predefined classes are given to you. But in clustering, you do not have any information, and you have to find out the natural groups. So this is very important task. It is very useful, but very challenging. And I will tell you why it is difficult. So some points are given to you, and you want to find out groups from that, such that points in a group are similar and points in a different groups or clusters are dissimilar. So this is the most important task that you want to do from in the clustering process. Why it is challenging? So there is a word, points are similar, our points are dissimilar. And this is quite interesting word. We will discuss that, why it can create a problem. Some of the application of clustering means everywhere, wherever you find the data, you can use it. For example, in marketing analysis, the managers want to know how many groups are there. So if they want to target a particular group, means if you want, as a manager, you want to make a strategy, marketing strategy. It is not a very good strategy if you target everyone. So you should target a group which have of similar customers. So the clustering is very important to find out the similar customers. In a medical, you can find the groups of similar patient. In web analysis, finding similar web pages. In finance, similar companies. In bioinformatics, document clustering. So the clustering is a very important task, and it has got application in almost all the areas. However, it is a very challenging task. It's not as simple as classification. In mathematical terms, when you define a clustering, we use some terms. How many points are there? How many data points are there? So number of records, let's say number of students. So the problem of clustering in generally deals with partitioning a data set consisting of n points. So that you have n students. Each data point is defined by some features. So in this case, it has been defined by m features. And you have to define, this is also a very challenging task, how many groups. So you want to make k clusters. So n points are given to you. Each point is defined by m attributes. And you want to create a clusters, k number of clusters from those endpoints. And such that points in one group should be similar and points in different groups should be dissimilar. Similarity. Now, there is a concept of similarity. I hope you can see this. Okay. Now, there are 8 points are given to you in the first row. We want to create some triangle and some rectangles, and they have colors. Now, if I ask you to create 2 groups from these 8 points, your answer may not be unique. One student may create groups on the basis of the space, the shape. They will say, okay, the concept of similarity is because of the shape. So all the triangles are in one group and rectangles are in another group. Well, good. The other student may say, look, the concept of similarity is based on the color. So I will create the group on the basis of the color. So blue color or light blue color in one group and red color in another group. So your answer is not unique. So the clustering, the concept of similarity is a very complex thing. And your final result will depend upon the concept of this similarity. And in the literature, it is unless until you are working in a particular domain and where you have a knowledge of that particular domain, it is there is no well-defined concept of the similarity. So that's why the clustering is a very challenging problem. So it is important that you should see this slide carefully and try to understand why it's a challenging task because the concept of the similarity is not unique. It can change. Now, there are different kinds of data sets. But generally, we find a data set of these 3 types. Numeric data. So if you are defining a data point like a student, we can say, okay, there is an age. So it's a numeric attribute. So when you want to define a student, there may be some attributes which may be numeric like age, GPA, 4.3, 8.4. Some of the attributes could be categorical data where you don't have numeric values. For example, the branch, mechanical or electrical, or color of the bike. Here you don't have any number. So these features data sets are called categorical data. And third, which is the most complex, is mixed. For a student, some of the attributes are numeric, some of the attributes are categorical. So a data set for the student could be a mixed data. And these kind of data sets are the most difficult data sets to deal with. This is an example. There are 2 attributes, height and age. So age, you can also define it by number, but here you have defined by some values, categorical values, like young, child, young, and old. So you don't have numbers. In height, you have numbers. So these data points, which the data point is, like say, for the student is 1 data point. So each data point is represented by 1 row. And the data set has got 2 attributes, height and age. Height and age. So there are two attributes. One of the attribute